Hello everyone. In an interconnected power system, there is a chance of faults occurring in the system. In order to protect the system from the faults, it is required to provide the protective devices such as circuit breakers. The circuit breakers will isolate the power system, the faulty section of the power system, from the rest of the system. In the module 5 of power generation, transmission and protection, we will be discussing on the circuit breakers and the associated device protective relay. First, we can see the circuit breaker operation. In this video, we will be discussing on the circuit breaker, the need of circuit breaker, where it is used and how it is operated. So what is a circuit breaker? A circuit breaker is actually a switch which operates automatically to protect an electrical circuit from the damage, like overload or short circuits. This figure shows the operation of circuit breaker along with a relay. Always a circuit breaker is associated with a relay so that the tripping action of the circuit breaker is initiated by the relay according to the fault condition. Here, a circuit breaker is connected in this transmission line which is to be protected. And this is the circuit breaker which is having two contacts, a fixed contact and a moving contact. And it is associated with a relay. The relay consists of these many parts where there is a current transformer connected in the transmission line to be protected, and there is secondary of the current transformer or the relay coil and a trip circuit. Trip circuit consists of a trip coil. When normal current passes through this transmission line, the current transformer will not energize the relay coil. The primary of the current transformer will not energize the relay coil. But when there is fault in the system, the current through the current transformer primary increases, and which increases the current through the relay coil also. So the relay coil energizes and this attract this magnet. This electromagnet will attract this moving part and this closes the trip circuit. When the trip circuit is closed, there is a DC source provided in the trip circuit and this will energize the trip coil. When the trip coil is energized, this moving contact is initially in close position with the fixed contact. These two are in close position. When the trip coil is energized, this moving contact is separated from the fixed contact, or the trip coil attracts this moving contact and which separate the moving contact from the fixed contact, and the circuit breaker is isolate the transmission line which is to be protected. So this is the circuit breaker and all other parts of the relay which will initiate the operation of the circuit breaker. So while separating the moving contact from the fixed contact, since the circuit breaker is working at high voltage and high current, the air between the contacts ionizes it forms an arc. So all the circuit breaker operation is associated with arc phenomenon. When short circuit occurs, the contacts of the circuit breaker begin to separate. The potential difference between the contacts is sufficient to ionize the air or oil or gas in between the contacts. This ionized air acts as conductor and this is called arc. When the arc is struck between them, even though the contacts of the breaker are opened. So when there is arc in the contact, arc is a conducting path which will again maintain the current through the circuit. Even though the contacts are separated, the current will remain in the system until this arc is extinguished, because arc forms a conductive path. So The current will be completely interrupted from the circuit when the arc is extinguished. The arc extinguishing depends on the resistance of the arc, degree of ionization, length of the arc, and also the cross-sectional area of the arc. So we can see some important terms associated with circuit breaker interruption. They are arc voltage, restriking voltage, and recovery voltage. Arc voltage is the voltage that appears across the contacts of the circuit breaker during the arcing period. And restriking voltage, it is the transient voltage that appears across the contacts at or near current zero during the arcing period. You know that the system is usually inductive and the current lags voltage by 90 degree, and at the current zero point the voltage will be maximum, and there is a large transience occurs at the current zero point. So this transient voltage that appears across the contacts at or near current zero is called restriking voltage. Then recovery voltage is the normal voltage or 50 hertz voltage that appears across the contacts of the circuit breaker after final arc extinction. When the arc is extinguished, the normal voltage will be appeared across the contacts. That voltage is called recovery voltage, and it is approximately equal to the system voltage, and the circuit is opened. Mainly, there are different theories associated with arc interruption. They are high resistance interruption, low resistance or current zero interruption. In high resistance interruption, the resistance of the arc is increased by cooling of arc or increasing the length of the arc or reducing the cross sectional area of the arc or by splitting the arc. In high resistance interruption, the arc resistance is increased to interrupt the arc. Resistance R equal to rho L by A. So we can cool the arc or increase the length so that resistance is increases, reduce the area or split the arc. By splitting the arc also we are reducing the area of the cross section. Then low resistance or current zero interruption is associated with energy balance theory and voltage rate theory. In low resistance or current zero interruption, the arc is interrupted at natural current zero. We know that at every half cycle there is a natural current zero point. So if we interrupt the current at that point, current zero point, it is called low resistance method. Energy balance theory states that if the rate of heat generation is greater than the rate of heat dissipation between the contacts, arc will be extinguished. So according to energy balance theory, heat dissipation rate is increased if the heat generation is greater than the rate of heat dissipation, arc will be extinguished. Then voltage rate theory, if the dielectric strength increases more rapidly than the restriking voltage, arc is extinguished. So, dielectric strength is increases rapidly more than the restriking voltage, then the arc will be extinguished. So, high resistance method is by lengthening the arc, cooling the arc, reducing the cross sectional area of the arc, and splitting the arc. And low resistance or current zero method is employed by mainly in AC circuit because it is employed only in AC circuits because it current zero, natural current zero occurs only in AC circuit. So arc resistance is kept low until the current zero where the arc is extinguished naturally and is prevented from restriking instead in spite of the rising voltage across the contacts. So at current zero, the arc is prevented from restriking. All the modern high power AC circuit breakers are with low resistance current zero method. The rapid decrease of dielectric strength of medium near current zero can be achieved by causing the ionized particles in the space between the contacts to recombine into neutral molecules. At the current 0 point, we can recombine these ionized particles into neutral molecule so that dielectric strength of the arc is reduced. Also, we can sweep away the ionized particles away from the path, and we can replace these ionized particles with unionized particles. So, depending on the insulating medium used in circuit breakers, the circuit breakers are classified into different types. There are mainly four types. They are oil circuit breakers, air blast circuit breakers, vacuum circuit breakers, and sulfur hexafluoride or SF6 circuit breakers. In the next video, we can see these types of circuit breakers in detail. Thank you.